Sounds familiar? It's freezing outside, the radiators are blasting so hard you could fry an egg on them, but your room still feels like an icebox. You're sitting at home in a thick hoodie, putting on a second pair of wool socks, and genuinely wondering where all the heat you're paying for is actually going. Well, I'll tell you where. Go to the outer wall of your house, or the wall next to the balcony. Just put your hand against it. Feel that? It's freezing, and this block of concrete or brick is literally sucking the heat right out of your room, 24/7. The logical next step is insulation, and this is where the fun and honestly the sad part begins. Any builder or contractor will tell you, bro, it's simple. Buy some mineral wool or foam board, build a wooden frame, pack in the insulation, cover it all with drywall, then plaster, wallpaper, and sure, they're right, it works, but there is one massive, gigantic problem. This kind of sandwich will eat up at least 3, maybe even 4 inches of your room space. And what if your room is already tiny, or it's a narrow balcony where every inch counts? Biting off half a square meter from your living space is a bit too much, don't you think? Plus, it's expensive, messy, and requires a full-blown renovation. So today, I want to show you an awesome alternative. We're going to make an ultra-thin thermal screen that works exactly like a regular thermos. And yes, to do this, we'll be using aluminum foil and bubble wrap. It sounds like some crazy TikTok life hack, but it's pure physics. It's incredibly cheap, takes up just a fraction of an inch including the finish, and it genuinely saves you from freezing walls. But I have to warn you right now, there is one crucial nuance. If you build this screen incorrectly, you'll just be throwing your money down the drain, wasting a ton of time, and your wall will stay exactly as cold as it was. Almost everyone who tries this for the first time makes this mistake. So watch this video to the very end so you don't repeat this stupid blunder. Let's get into it. Let's be physicists for a couple of minutes, but without the smart formulas and boring terms. How does heat actually escape our cozy room into the freezing outdoors? Heat has a few ways of escaping, and one of the main ones, which many people forget about, is thermal radiation. Oh yeah, your hot radiators, your space heater, your cat, and even you, we all emit infrared heat. Those infrared waves fly across the room, hit the plain concrete wall, and the wall happily absorbs that heat. And since it's cold, it immediately passes it further outside. It acts like a pump, draining your heating budget. Massive, classic insulators like mineral wool fight this phenomenon with brute force. They just create a very thick barrier that heat struggles to push through. But what if we don't build a thick, solid wall? What if we just bounce that heat right back into the room? Think about a regular metal thermos that you pour your coffee into when you go camping. It doesn't have 4 inches of foam or fiberglass in it. A thermos is thin. Inside, it's just a flask with a mirrored coating and a small layer of emptiness, meaning a vacuum. The mirror reflects the thermal radiation back into your hot drink, and the emptiness stops the outside cold from getting in, because a vacuum has no molecules to transfer the temperature. We are going to steal this exact brilliant idea for our wall. Look at how it works in practice. Regular aluminum foil will act as our mirror. It can reflect up to 97% of thermal radiation. That means the heat from your radiator hits the foil and bounces right back to you on the couch like a tennis ball. The room starts heating itself. But if you just take shiny foil and stick it directly onto an ice-cold wall, it will cool down instantly and it'll be absolutely useless. Foil is metal, and metal is a fantastic conductor of temperature. Touch any piece of metal outside in the freezing cold and you'll know what I mean. We need isolation from the cold wall itself. We need that layer of emptiness just like in a thermos. And this is where it steps onto the stage. The great, terrible, and universally loved bubble wrap. The exact same anti-stress packaging they wrap your deliveries in. Do you know what the best, most effective, and completely free heat insulator in the world is? It's ordinary, still air. Specifically, still air. Inside the bubbles of our wrap, the air is trapped. It can't move or mix. This wrap creates a barrier and stops our foil from touching the freezing concrete. It makes a perfect combo. The bubble wrap cuts off the cold from the wall, acting as an air cushion, and the foil reflects your room's heat back inside. And all of this takes up, well, maybe 1/4 of an inch in total. Anyway, enough theory. Let's get down to business. How do we build this with our own hands? What materials do we need? First, bubble wrap. The rule here is simple. The bigger the bubbles, the better. Bigger bubble means more trapped air, which means a warmer wall. Second, foil. You could, of course, just use heavy-duty kitchen foil for baking, but it's better to run to the hardware store and buy a roll of builder's foil. It's tougher. Crucial note, you need actual metallic aluminum foil, not just that shiny plastic film they wrap flowers in. Third, some good, grippy, double-sided tape. By the way, a quick side note for the lazy ones, hardware stores actually sell materials like foil-faced bubble insulation or Reflectix. It's a ready-made foam or bubble backing with foil already attached. It works on the exact same principle. You can just use that. But building a thermal screen yourself from leftover shipping bubble wrap is true DIY. Plus, you can often get the wrap for free from your deliveries. So, the step-by-step process. Step 1. Preparation. It's boring but mandatory. The wall must be dry, clean, and flat. If there's mold, you must kill it with a special cleaner. If there's peeling plaster, scrape it off. Step 2. Grab our double-sided tape and stick it to the wall in a tight grid pattern so the wrap holds well and doesn't sag. Step 3. Carefully press the bubble wrap onto the wall. Make it tight without big wrinkles. Which side to glue it on, bubbles facing the wall or outward, actually doesn't matter much. The physics will work either way. But it's better to stick it with the flat side facing you towards the room. It'll just be fundamentally easier to apply the next layer. Step 4. On top of the bubble wrap, we stick our foil. Again, you can use double-sided tape or special aluminum foil tape for the seams to make everything airtight. And right here, guys, pay absolute attention. The shiny, mirrored side of the foil must face the room. It sounds incredibly obvious, right? But you have no idea how many people glue it with the shiny side facing the wall. What is it going to reflect there? The concrete? Your neighbors? Always point the shiny side towards the heat source. And now we get to that exact nuance I warned you about at the very beginning. The very mistake that leads to tons of angry reviews online saying, "Your foil doesn't work. I glued it all up and my house is still freezing. It's a total scam." Listen carefully. Many people follow the instructions perfectly. They stick the bubble wrap, they stick the foil with the shiny side facing the room, and then they go and glue their wallpaper directly onto that foil, right up against it. Or they screw decorative panels flush against the metal. Guys, you absolutely cannot do that. For the foil to act as a mirror and reflect thermal radiation, there must, do you hear me? There must be an air gap in front of it. Air must be able to touch the foil freely, at least half an inch, preferably a full inch of empty space. You see, if you stick wallpaper over the foil or press a sheet of drywall right against the metal, the heat transfer will no longer happen by radiation, it will happen through direct physical contact. The infrared waves will have no room to travel. There will be no radiation, and the foil will just pass the heat straight through to the wall and become a useless piece of metal in your setup. How do you do it right? Once you've stuck up our bubble and foil screen, you screw thin wooden battens directly over it, right through it into the wall. Just thin strips, maybe an inch thick. You create a light framework, and then you attach your final finish, thin drywall, wood paneling, or plastic siding onto those battens. Between your wall covering and the foil will be empty space, that crucial air gap. Yes, this structure will add an inch or two to your wall's thickness, but agree that's still 3 times thinner than building a massive frame from mineral wool, right? The gap is mandatory. Remember it, lock it in. Without it, none of this makes any sense. Now let's talk about the honest downsides. I want to be completely transparent with you to the end. This isn't magic, and this method has its flaws that you should know about before you drive to the store. Downside number 1, soundproofing. Bubble wrap and foil won't save you from a neighbor's hammer drill or loud music at all. The acoustic insulation of a screen like this is practically zero. It is strictly for protection against the cold. Downside number 2, and a much more serious one, the dew point. If the wall in your house is thin, poorly heated, and freezes all the way through so much that ice forms in the corners in winter, this kind of thin internal insulation can play a cruel joke on you. It will shift the dew point inside the room, right under the film. Condensation will start to build up there, and where there's moisture and warmth, black mold follows. So, this method is perfect for chilly walls, loggias, or brick houses to make a room cozier. But if you have an emergency-level freezing wall in sub-zero winters, I'm sorry, foil won't save you here. You'll need proper heavy-duty insulation, ideally on the outside of the building, not the inside. And downside number 3, a purely practical one, hanging a heavy bookshelf, a kitchen cabinet, or a heavy TV mount on a wall like this will be slightly more difficult. You'll have to find extra long wall plugs to punch through your finish panel, bridge the air gap, go through the insulation, and securely anchor into the load-bearing wall. It's a minor thing, but something to think about in advance. So, what's the bottom line? An ultra-thin thermal screen made of bubble wrap and foil, or ready-made foil-faced bubble insulation if you don't want the hassle, is a genuinely awesome, effective, and very budget-friendly life hack. It'll save you on a freezing balcony, at your cabin, in the garage, or in a corner apartment where you constantly feel a draft from the wall. And most importantly, it'll preserve your precious room space, which we never seem to have enough of. Try doing this just on a small test section of your wall and see for yourself how much warmer it gets. You can't cheat physics. If this video was helpful and you learned something new, don't spare a second. Hit the like button